Hey everyone, welcome to today's tutorial on visualizing k-mean clustering using TensorBoard. In this video, we'll break down how to use TensorBoard for visualizing the k-mean algorithm and its iterations. I will guide you through every step of the process and explain how TensorFlow works behind the scene. So by the end, you will know how to integrate TensorBoard in your machine learning workflow for better visualizations. So first thing first, k-mean. What is k-mean? K-mean is a simple yet powerful unsupervised learning algorithm used for clustering data points into groups or clusters. See, the objective is to partition the data in k groups where data points within the groups are more similar to each other than those in the other groups. The algorithm iteratively reassign points to the nearest cluster centroid and update the centroid until the convergence. So first thing, you need to set up your environment. If you don't have TensorFlow installed, you can install it. You use this command to install TensorFlow, Matplotlib, and TensorBoard. Next, we will start importing the required libraries. So TensorFlow will be handle the k-mean clustering process. The Matplotlib will help us plot our data, and TensorBoard will visualize the k-mean progress over iteration. Right? Let me run this. Next, we'll just generate some sample data. So we need data of two cluster, right? For simplicity, we'll generate some random data using the make blobs from scikit-learn. So this create random data points group around few clusters, perfect for demonstrating the k-mean. So if I run this, the make blob will generate the nx or y, though we are not going to use the y. Next, let's plot our data and see how the data looks like. So this is the sample data. As we can see, there are 4 clusters in this. Now let's initialize the k-mean clustering operation. So we will define our centroid as variables in the TensorFlow. So these centroids will update over each iteration to find the optimal cluster center. TensorFlow uses tensor to represent all data, and we will be manipulating this tensor using the during the optimization process. So to explain the code here, the TF variables, this is used to represent the centroid. Since TensorFlow operates with tensors, we initialize the centroid as TF variables so they can be updated during optimization. TF random normal, so this generate random starting centroid, right? Let me run this. Next is our TensorBoard setup. So to visualize the optimization process, we will use TensorBoard. TensorFlow integrates perfectly with TensorBoard, allowing us to log scalar values, images, histogram, and more during the training. Here we'll log the centroid position after each iteration so we can track how they evolve. So we use the center file writer. So this inside the directory to store log files. This is where TensorFlow will look for a log data. Now let's set up that and run this. Next is implementing the clustering loop. So now comes the iterative part. We will perform the core k-mean algorithm with a loop. In each iteration, we will first assign each data point to nearest centroid, and second, they upload the centroid based on the mean of the point assigned to them. So let's break it down. So the assign cluster function calculate the distance between each point and each centroid, and then assign each point to the nearest centroid using TF argument, minimum distance. Next is updating the centroid. So this function compute the new centroid for each cluster by taking the mean of all the point assigned to that cluster. So let's run this. And now we are, I'm not using the session, but let's iterate over the each data point. So training loops will with eager execution, and it will log the centroid to the TensorBoard, and it will print data point after each 10 iteration. So let's see. So came in iteration 0, right? After 10 iteration, after 20 iteration, after 30, and finally 40 iteration. So using this command, we can open TensorBoard directly into the Google Colab. And as you can see, once also in case you want to open the TensorBoard, you can use localhost 6006 port, and that will open the TensorBoard. So here you will see the scalar plot showing the each centroid coordinates changing over time, right? And this is a powerful way to visualize the optimization process and understand how the centroid converge to their final position. See, right? So that's it. Congratulations, you have successfully implemented the k-mean clustering in TensorFlow and visualized the process using TensorBoard. There is a separate video on this and TensorBoard I have created already. Please check in the playlist. So this combination of TensorFlow and TensorBoard gives you an interactive and real-time view of how machine learning algorithm evolves. And by tracking the centroid in every iteration, you can give valuable insight into your models. I hope this tutorial helps you understand the k-mean clustering and how to use TensorFlow and TensorBoard effectively. Thank you for watching. I will see you next time.